Hello, welcome to Thriller Behind Chemistry. Today we have to discuss about the reason behind chemical combination. We have no hand in chemical combination but need to know why and how it's happening, the reason behind it. So today's topic on the basis of why. We all know that every concept, theories or rules comes forward for a specific reason. Here's what we know: every system have a tendency to be more stable. As in chemical science, every atoms or elements or any participating constituents have a tendency to acquire the stable electronic configuration as like the nearest noble gases. From previous discussion, according to Lewis, we all know that in noble gases the outer shell's 8 electrons occupies at the 8 corners of the cube which surrounded the kernel, that is nucleus plus inner electrons. And according to the scientist, this is the most stable electronic configuration which have lowest energy. So the conditions for the stable electronic configuration is the valence shells have to 8 electrons. So based on this, a rules, a concept comes forward, that is octet rule. So the octet rule based on the inertness of noble gases, and that rules was a thought which approaching the atom to share or gain or donate electrons to acquire the stable electronic configuration as like nearest noble gases. So what is the description of octet rule? The octet rule was a thought which approaching atoms to share or donate or gain electrons to attain the stable electronic configuration. So we chemistry lovers knows it very well that chemistry does not contains any specific or perfect laws, theories or concepts. Our great scientists notice a problem, discover a theories with assumption, postulation or limitation, and then they noticed another exception and so on. So we the chief students can say that for chemistry any rules, theories and also assumption, postulation or limitation till now are not perfect. All are wrong, but those are the roots of chemistry. As well as the octet rules have also a limitation and exception. The octet rule is very useful for understanding the structure of most of the organic compounds, but not universal. And they notice that the octet rule mainly applied to the second period element of the periodic table, and as well as the octet rule shows exceptions which are 3 types. So first clean it. So the first point is the incomplete octet of the central atom. So there in some compounds the number of electrons surrounded the central atom is less than 8, that is they can't acquire the stable outer octet electronic configuration, especially with the elements having less than 4 valence electrons. So the elements having less than 4 valence electrons. For example, lithium chloride or BeH2 or boron Bcl3. That is in isolated lithium, that is in free atoms of lithium have only 1 electrons of valence shell. So less than 4 valence electrons, and chlorine have 7 electrons but share only 1 electrons. So lithium chloride. The Lewis structure as this. Beryllium also have 2 valence electrons in isolated state or free atom of beryllium. So less than 4 also beryl, and 2 hydrogen atoms contributes 1 electrons each. That is, beryllium also have 4 valence electrons in molecules. Lithium have 2 valence electrons in molecules, that is lithium chloride. As this boron have also 3 valence electrons in free or isolated state. So this is the boron's own electrons, and these electrons contributes by chlorine. So borons have also 6 outer shells electrons, that is valence electrons in molecules BCl3. So octet rule does not fit there. And the next point is the odd electron molecules. So that means when in molecule contains atoms which have a odd number of valence electrons, like nitrogen. For example, in nitric oxide, that is NO. For nitrogen dioxide, that is NO2. The octet rule is not satisfied for all the atoms. How? The nitrogen have 5 valence electrons, that is 1, 2, 3, 4, 5. For nitric oxide, oxygen have also 6 valence electrons. To attain the stable outer octet electronic configuration, oxygen have to bond with 2 electrons of other atoms. So there oxygen bonded with nitrogen via 2 electrons, and there oxygen attains the stable outer octet cells, that is 1, 2, 3, 4, 5, 6 and 7, 8. But for nitrogen have 1, 2, 3, 4, 5, 6, 7 valence electrons. So here nitrogen cannot acquire the stable outer octet electronic configuration. So in case of nitrogen dioxide, nitrogen have 5 valence electrons, and each oxygen atom have 6 valence electrons. 1, 2, 3, 4, 5, 6. Another is 1, 2, 3, 4, 5. And here nitrogen can afford a maximum of 3 bonds, that is triple bond. And each oxygen atom, to attain stable electronic configuration, have to be bonded with 2 other electrons of the other atoms, that is double bond. So one oxygen atom can make double bonds with nitrogen, but for the next oxygen atom it's difficult to make double bond, because now nitrogen have to bond with others as a single. So now this oxygen atom attain stable electronic configuration, but this oxygen atom till now can't attain. So here the oxygen is more electronegative than nitrogen, so oxygen attract the electron cloud of nitrogen to gain stable electronic configuration, and nitrogen also donates an electron to oxygen. So here and for donating an electrons to oxygen, nitrogen have a formal charge of +1, that is, and to gain an extra electron on oxygen have also a formal charge of -1, that is, here each oxygen atom attain now stable electronic configuration, but for nitrogen 1, 2, 3, 4, 5, 6 and 7, nitrogen cannot attain the stable electronic configuration, and that is the second point of exception of octet rule. And the third point is the most important. So first clean it. So the third point is the expanded octet, that is So what's about the expanded octet? The elements in the third period of the periodic table have, apart from 3s to 3p, there are 3d orbital also available for bonding. They are empty but available for bonding. In a number of compound of these elements, there are more than 8 valence electrons around the central atom, and this is the termed as the expanded octet. For example, the PF5 phosphorus have 5 valence electrons, and phosphorus can make 5 individual bonds with 5 fluorine because of the availability of the 3d orbitals. So phosphorus have 1, 2, 3, 4, 5. Here around the phosphorus there are 10 electrons, that is more than 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we now realize that the octet rule does not apply in such cases. Again, for H2SO4, that is the central atom is the sulfur because of the more electropositive than hydrogen and oxygen, and we know that the most electropositive atoms in the molecule occupy the central position. So here the sulfur is the central atom which have 6 valence electrons. So sulfur has 6 valence electrons, 1, 2, 3, 4, 5, 6, 3, 4, 5, 6, and 4 oxygen atoms each have a tendency to make double bonds for attaining the stable electronic configuration. So there one oxygen atom make double bond, there one oxygen atom make double bond, and there are 2 oxygen atom make single bond, and the 2 hydrogen atom bonded with those oxygen atoms which have a single bond with sulfur. So in the case of sulfur, sulfur has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 valence electrons. So here obviously the octet rule does not apply. Or for example SF6, sulfur has a 6 valence electrons, we know that. 1, 2, 3, 4, 5, 6, and sulfur can make 6 independent single bond with 6 fluorine because of the availability of 3d orbitals in sulfur. So there are also 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 electrons around the sulfur atom. The octet rule does not apply here, but all over sulfur atoms does not show such types of exceptions. Sulfur also forms many compounds in which the octet rule is obeyed, that is for sulfur dichloride. Sulfur has 6 valence electrons, that is 1, 2, 3, 4, 5 and 6, and chlorine, the halogen elements, makes only single bond for attain stable electronic configuration, that is chlorine. So here naturally chlorine attains the electronic configuration by forming single bond, but here sulfur obey the octet rule, that is sulfur has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. Clear? And at last we discuss about the such drawbacks of octet theory which make the octet rule as handicapped. So we know that the octet rule is based upon the chemical inertness of noble gases, but can't explain why some noble gases like xenon, krypton also combine with oxygen, fluorine to form a number of different types compounds like ZeF2, like KrF2, like ZeOF2. The octet rule can't explain such types of drawbacks. That is, the xenon, krypton already have a stable electronic configuration, but why they combine with other needy elements? This theory can't explain. And the octet theory also silent for the shape of molecules. And other drawbacks of the octet theory is it can't explain the relative stability of the molecule as well as the energy of the molecules. That is, the octet rule only approach atom to attain stable electronic configuration, but about their energy the theory almost silent. So that's it. So the discussion will end with a question from IIT 2006. That is, the octet rule is not valid for the molecule A. Carbon dioxide, B. H2O, C. Oxygen molecules, and D. Carbon monoxide. So what is the right answer? For carbon dioxide, oxygen has 1, 2, 3, 4. Oxygen has 1, 2, 3, 4. Carbon has 4 valence electrons, which all are involved in bonding with oxygen atoms, and the carbon attains stable electronic configuration, and to each oxygen attains stable electronic configuration. So carbon dioxide is not the answer. For H2O, oxygen have 1, 2, 3, 4, 5 and 6, and hydrogen each can make only single bond. That is, so for hydrogen to attain stability have to be doublet in the valence shell. So hydrogen attains that, and for oxygen 1, 2, 3, 4, 5, 6, 7, 8. Oxygen also attains stable electronic configuration, that is octet. So H2O is not the right answer. So for oxygen molecules 1, 2, 3, 4, 5, 6 and 1, 2, 3, 4, 5, 6. Both for attaining the stable electronic configuration have to make a double bond. So here the sharing of the two paired electrons makes them stable, that is, they each now attain stable electronic configuration. So O2 also is the not right answer. So then 3 answer is the wrong. The last one is carbon monoxide. This is the right answer or the question is wrong for IIT 2006, mind it. So let's see that. For carbon monoxide, carbon have 4 valence electrons, that is 1, 2, 3 and 4, and oxygen have 6 valence electrons, that is 1, 2, 3, 4, 5, 6. So to attain electronic stability, oxygen have to bonded as double, that is 1, 2. And then naturally oxygen attain the stable electronic configuration, but carbon cannot. 1, 2, 3, 4, 5, 6. The 6 valence electrons around the carbon in carbon monoxide, it's natural, but in nature carbon monoxide exists as triple bond, which can't explain by the octet rule. So the answer is carbon monoxide. So clear? And last, I requested you, as anywhere I was wrong, please comment below.